Hey Patreon supporters, this is Peter coming to you from my classroom at Idea High School in Tacoma, Washington. The video that you're about to watch is extremely long because it's designed for absolute beginners. It walks you through every single step of assembling one of my guitar pedal designs, including like what kind of solder to use and just soldering technique, how to install circuit components. So if you have a lot of that experience, this video may not be completely for you, so I will timestamp all the different sections in case you want to investigate more in one of them. I'll also be creating a short document that just gives you kind of the step-by-step instructions, so if you've done it before, you don't need to watch an hour-long video. But if this is your first time, I encourage you to watch it while you're building and pause the video as you do certain steps. All right, thanks for watching and thank you for supporting me on Patreon. So today I'm going to be populating the pinball circuit board. But as I do this video, it won't be pinball specific. I'll just be using it as an example. So I'll be going through some things that aren't even in the circuit board, just to lay all the examples that I can right now. You'll find in the documentation two files. One has the layout along with all the parts in that board, and then a master sort of parts breakdown with this one has standout pinball and dragon. More effects will be added over time. This document is meant to be not really in print, but mostly digital, so you can click on the links and easily source those parts for yourself if you don't know where to find them. This one though is great to print out or have like on a screen next to you as you're building, because it has all the parts for that in the order that I recommend that you build them. To make it easiest, as well as some mod sort of like what things affect the tone of the circuit and in what way. And I won't go into great detail in this video for time's sake, but I'll go into more detail later. So here we go, let's go ahead and get started. So I'm going to set this aside because I don't need this for the building. This is just to be able to source the parts. And I'm primarily going to use this sheet. And so I'm going to go in order from top to bottom, because what I've done is I've put some of the shorter parts here and then moved this way towards the taller parts, so it makes it a lot easier to put in. You'll notice I already have, and let's see here, get this up in the screen. I already have the microcontroller, which is the 12F509 on the sheet. The very first thing. There you go. This will be pretty common. I don't think it'll be every single time, because if it's just a bunch of loose parts, but a lot of times with these ICs, just for packaging sake, it's easier for me to just put them in myself than to like create special packaging for them, because they've got a lot of legs that can be easily bent. Anyway, I'm going to put that down there. Let's go ahead and move on to the next type of item, which are on here it says DPDD slide switch, which is this little tiny guy. This will be used most often for like buffered versus true bypass, if the pedals can offer that. The other type of switch that sometimes you'll see almost all the time, is this relay switch. See if I can get that close. And another switch that's not in this board is called a dip switch, but you'll see them in some projects, and this allows for multiple. You've probably seen these before. They can do a lot of different switching options. Those ones are actually really easy to install. So a couple notes on these switches. First, the slide switch has a slide switch on it. Let me get in the video. Slide switch here, back and forth. You want to always point that slide switch part towards the actual text near that part. So it says buffer and true bypass. So I want to actually point that up towards that. Also, anytime you have, let's see if we can get this in the video. Anytime you have legs that are really, really close together, I recommend that you don't fold them towards each other, because it makes it a little more difficult in the soldering process. You can do so, but you'll have to do some extra clipping or whatever. I'm going to actually fold both of these up, and it's in there nice and firm, and they're not close. I'm not going to accidentally solder them together later. With the relay switch, and this might be really hard to see, so I'm going to get it close to that. Get it close. Can it refocus? I don't know. Can you see the stripe on this end? There's a stripe on one end of the relay On the circuit board itself, there's a notch, and that's the stripe and the notch. They indicate the same side, so you want to install it the correct way. I'm not going to do it right now because it's a taller component, but I wanted you to see all the different kinds of switches and how they're oriented. So as I go down the list, I have a 1N4148 that is in a diode, and it's got an orange glass body with a black stripe. Diodes will always have one stripe that's a different color on one end. Let's see if I can get these close enough. Let me get some light on these. So here we go. Here, let's see if the iPhone will actually refocus. Refocus. I'm close. There we go. That's a little better. Anyway, the striped side is actually indicated on the silk screen. It's very clear if you look right there. You can see a stripe on this side, and then on this diode there's a stripe on the bottom side. Then up here, this diode has a stripe there. So I'm going to go ahead and put in the 1N4148 diode. Now, if you're getting this as a full kit, so it's got all the parts in it, there are other diodes that look like nearly identical. And in little tiny print around this orange body, and there's no way this camera will pick it up, it's actually printed what it is. So it says 4148 on here, and the other diode that looks similar to this actually says 20 for the 20 volt Zener, and you'll see that on the list. So I'm just going to fold these here like so. Stick it in so the black stripe matches the white stripe. And then I'm going to fold crisscross applesauce. I'm going to push real tight. Make sure it's in there nice and firm. Okay. All right, now let's go to resistors. The next thing, it says 1 by 470 8th watt resistor. So anytime you see wattage rating, that's definitely going to, I shouldn't say definitely, but almost always it's going to be a resistor. And so I've got this smaller 8th watt resistor. It's really, really small. These resistors, you can tell what their value is by actually reading the color code of the stripes on them. I don't have time or the space to go through that in this video, but there's plenty of resources. Just Google how to read a resistor value, and you'll see charts and all that kind of stuff. Anyway, I'm going to do the same exact thing, fold it the same exact way, and insert it where it says 470 on the board. And crisscross fold here. I wanted to show you a few different, few resistors that just look different than the others. So this is a carbon film resistor, so it's just a different color. It's like a beige or off-white. And this is a jumper, which is basically like a wire. And if this could focus clear enough, you would see it actually only has one single black stripe, and black means 0 in the color coding world. And so it just means it's just a wire. Now, you can actually use literally just a wire, or if you were to clip off the ends of one of these, you could just use that. But and so where it says jump is where I put that one in. And then this other carbon film one, it's the only one like it, is the 10 mega ohm. So I'll stick that one on. All the same process here for these resistors. Just FYI, this jumper resistor down here, in most boards the jumper resistor is there simply to allow normal power operation. If you remove it, you can install down here, and this will be something I'll explain later down the road. This essentially is a pinout that allows you to connect a charge pump. So you can plug in 9 volts, but it's running at like 18 or 25 or whatever you want to put it at. Okay. Through that. Okay, a couple notes. I'm not going to put these ones in. But down the list, you'll see quarter watt. I'm actually moving away from this. I'm going to be using all 8th watt resistors, those smaller ones you just saw, in future designs, just because it allows to, the pedals don't take that much power, so it's not like I don't need a resistor that has quarter watt. And I'm trying to make them compact and have a lot of features. So Having a smaller resistor will help me do that. But some of them will require it, and these first ones will. And sometimes they'll be blue, and sometimes they'll be red. The blue ones have the stripes, like most resistors. The red ones actually print the actual value on it, so you can just read it, which is nice. Okay. All right, moving down the list, where it says 0.1U yellow. This will be found in just about probably every single one. This is just a little power filtering cap that's used as a charge reservoir next to active components. Don't worry about what I just said. Just know that this is what it looks like. And on the little body, it will say 104 to indicate that it, and another video will explain why, but if it says 104, it's this 0.1U yellow. So I'm going to stick this one in. It's actually in 3 places. I'm going to stick it in one of them. But this one, because so here's a not that technical, but a little bit technical. How far apart the legs are is called lead spacing. Those small resistors I was just doing have a lead spacing of 5 millimeters. This is half that size, so 2.5 millimeters. Or if you want it in English imperial units, that would be 0.2 inches and 0.1 inches. So because they're closer, I'm not going to actually fold them towards each other. I'm going to fold them away from each other. Okay? Again, you don't have to do all these things exactly this way, but this is what I recommend to make sure you don't make any mistakes or get something that is connected in the soldering process that it's not supposed to be connected to. Okay. Moving down. All right. There it calls for an inductor. So I'll just show you what that looks like. The 1mH inductor. This is also used in, so it's like a fat resistor basically is what it looks like. Get to that later. And then it calls for an op amp. So the op amp and a lot of these components that look like a little microcontroller here. Let's see if the camera will refocus for us. Yeah, there we go. So right here is a microcontroller, or an MCU for short. And on it, it has like a notch to indicate which orientation. Sometimes there'll be a dot up on the first pin here to indicate orientation. This one actually has both. Sometimes it has both, but they're in opposite location. The dot's on one end and the notch is on the other. The notch always supersedes, so if you see a notch, use that. But that's how you know which way to orient it. Now, with these ones, the pinball calls for a JRC 4580, but you'll notice actually on the board itself, it just says dual op amp. So there's a lot of different dual op amps that'll work great. And if you want to experiment, you can go ahead and socket. The one thing that I'll do want to note just about op amps in general, it's very, very rare. There's very few circumstances where there's this one op amp that's just significantly better than all the rest. And when those situations occur, it's usually for some very specific reason, specific task, not some general task, like general amplification, which is what this is doing. And so what you'll find is there will be like 5 or 6 op amps that all work great. And there might be 5 or 6 op amps that work terrible in that circuit. So I have the ones that I'm using, but you're certainly welcome to experiment. And so we actually socket them in the production run, so end users can do that as well without needing to desolder them. Okay, so moving down the list, I'm not going to install those. That's how you would install them. You don't need to socket them if you are using this. Just go ahead and put it in normal. And if you don't know what a socket is, definitely don't socket it. Just put it in. Okay, so I did the relay. Okay, so the thing that says 3362P, that is a blue Trimpot. Looks like this. This is a potentiometer, but for the inside of the pedal. It has 3 legs. Those legs form a triangle, and it's basically impossible not to get it to line up correctly. This one's a 20K, which I use for all of the to control the brightness of all the LED and all the pedals. So you'll see at least one Trimpot. This one only has one. Some have more, but that's what it's used for. Also, Unless otherwise noted in my designs, I make the stocked setting 12 o'clock. I strive for that if possible, just because it allows the end user to easily customize it and come back to where the stock level is. But there are some circuits that require special tuning, and it won't be at noon. But that will be noted. Okay. Okay. Last 2-3 things. Okay. Yeah, here we go. So this 15 NF capacitor, it even says 5 millimeter spacing. There are some that have 2.5 millimeter spacing, so I'll show you those two here. So this one's got the 5 millimeter, this has got the 2.5. So as I install this one, I'm going to fold the legs together when I put it in, whereas the other one I would have folded their legs apart. Now the pinball doesn't call for that other one, I just wanted to show it to you. So I'm going to fold their legs towards each other. And then we have, this is the voltage regulator. It's the LP2950 on the sheet. But there's also lots of transistors that have the same body shape. And so it's like a black plastic body, and I think you can see it there. It's like a half moon shape, semicircle. So the curved side and the flat side are indicated on the circuit board. So you just make sure that those match up. So I'll do that. Fold those legs down. And then finally, talking about polarized capacitors. So here is a tantalum capacitor. You'll see it has one leg that's longer than the other. Here's an electrolytic capacitor. It also has one leg that's longer than the other. The longer leg indicates the positive side. It's also indicated on the body of the capacitor itself. This one actually happens to be non-polarized, so it could actually be inserted either way. But as a general rule, we'll just make it a good habit. I'm going to stick this longer leg in the positive hole and the shorter leg in the negative hole. And the positive leg will be marked, and oftentimes it's also a square hole. Okay, so obviously I have not installed everything and not done it in an exact order, but I wanted to show you just kind of how that works out as far as like how to orient the parts and install them. Now I'm going to show you really briefly is kind of an ideal way to clip to make sure that you can solder them cleanly and not have a giant mess on your hand. So I use the ProSkit 8PK-30D flush cutters. You can, I think they're like $8 or something like that. You can find other brands and stuff, but this is the one that I've sort of has been my go-to now. And so when I'm cutting the traces, see if I can get it here, get any light. Get some better lighting. So I'm going to essentially, there's the metal pad that goes around the hole there. I want to cut just outside of that hole, so that just outside of that pad, so that I make sure that this part's not going to get loose or fall out. But I don't want to go much past the edge of that pad, because then it can be too long and interfere with other components and potentially touch other metal traces on the board. And so I recommend clipping it about there we go, about there. So let me clip the rest of this, and I'll show that to you. At the end of this section of the video, I'll show you a picture of a fully assembled board that's been clipped, so you can get an example of what it kind of looks like when it's done. Now, when it comes to this step, I recommend doing only 5 or 10 components and then clipping them if it's your first time. If you've been doing a lot, you know what you can get away with, but if it's your first time, do 5 to 10 and then clip them so you have lots of space to work with so you can easily see. I'm going to go ahead and stuff the rest of this board and then show you the soldering stage. All right, so we are now ready for soldering. But before I get started here, I want to kind of mention some of the tools that I'll be using. So the solder that I'm using here is, let's see if we can get that so you can read it. It's the Kester, and then down here, you can see it says K100LD. I'm using that because of it's lead-free and it's easy to work with, easy to solder with. I'm also using a 0.025 inch radius, diameter, there we go. It's just slightly smaller than what's standard. I think standard is 0.032. And using that smaller one, just again, because it's less solder at a time, it helps it flow better, more consistency. So that's why I do that. You don't have to, but I do recommend not using like a 60-40 blend, which is has lead in it, but it's also just, it's not a very good solder for long-term reliability and consistency in terms of the joints. So you can do some research online, but that's the one I use. I've used some eutectic solder blends. You can look up that word. It just means that the metal blend allows for them essentially to melt as one and to solidify as one all the metals within there. And so that just makes for a nicer soldering process. So the solder you choose will have a big impact on just how easy it is to solder and how consistent your solder joints will be. But your technique even more so. So I'm going to go over that. So I'm going to try to get this board in such a way so it doesn't have that giant glare. I like to use a clamp because that way the board does not rock back and forth while I'm soldering, so it's in there nice and sturdy, so I can put some pressure on it without it shifting. Let me turn on the soldering iron. I also have a just a brass mesh tip cleaner for cleaning the tip. I prefer this over like a wet sponge, which is pretty common because it doesn't, a wet sponge will cool down your tip and make it last, it's just harder on the tip because as you can imagine, it's your really hot tip and going into the water all the time is cooling it down and going through whatever. Wow, I'm having troubles here. Anyway, point being, I recommend some sort of wire mesh tip cleaner. So I'm going to see if I can get this in the camera a little bit. So I'm going to clean the tip. And I'm going to tin my tip. And then I'm going to solder each solder joint. Now, for those of you who are experienced, you don't need to watch this part of the video. But for those of you who are newbies, this will be a good experience. So I'm going to get this one in the corner first and then get one where you can see here. So hopefully you can see these solder joints up here. What I'm going to do is I've put a little bit on to the soldering iron, and then that's called tinning the tip. And then I'm going to press that against not just the part that's coming out, but also the hole. And so when I do so, I'm heating both sections up at once. So, and also you'll notice I'm not actually putting solder on the tip itself, but coming here to the side, going essentially for the hole. And if I've heated those elements, and I've sort of tinned that, it should go pretty smoothly. What you're looking for really is that the solder is going through the hole, that it's smooth, there's no like giant dome. You don't want to push so much solder that it goes through the hole and there's this ball of solder coming out the other side. I've seen that plenty of times. Oh, create a soldering pattern. Right now I haven't really been going in my soldering pattern, and if you'll see, I've actually missed a couple of things up in this section. And typically I actually have like a pattern that I go across the board that allows me to sort of weave across the board and hit everything, and I'm much less likely to miss something. And then when you're done, of course, go back and double check to make sure all your solder joints are in there perfectly. Also, I should note that if you're using the standout board, which is a white board, The rosin in here is yellow. You can't see it on this black because it's a very translucent yellow, but you will see it quite clearly on the whiteboard, and that's just normal. Anything else to mention? I think that's it. Oh, yeah. So there are anything that's empty, any of these empty holes, you want to leave them empty because we're going to use them later. Don't just fill up a hole because it's there. You want to solder something where it's got a component that you just installed sticking through. You want to solder those solder joints and nothing more. I'm going to try to attempt to do a bad solder joint. Okay, that one right there. So you can see it's more of a ball than something that flowed into the circuit board. And so I'm going to put some more heat on there. Okay. Now, that one was actually probably not too bad. As I told you, I was going to try to, because when you got good equipment and good solder, it becomes tough to actually do a bad one. Typically what I find when students are doing bad solder joints, it's either because their tip has become oxidized, so there's no, like, you can see oxidation actually all along this, and then on the tip here we actually do have some metal that's clear, but as you can see, if I heat up the tip, it melts nice and good, but if I put the solder here against the oxidized part, all it does is pool up, and that'll cause you to have bad solder joints for sure, because the heat transfer is just not that good. Another thing that will, let me turn that off so it doesn't oxidize while I'm talking. Another thing that will cause a bad solder joint oftentimes is if you stick this on here and you put the solder on the iron itself and not to the joint, or, and this is the most common thing with students, you touch really lightly. As you can imagine, if this was really hot and it just brushed your skin, it wouldn't hurt too much. You'd feel it, but it wouldn't hurt too much because it's really hot. But if you took this and you pressed it into your skin, that would hurt a lot because the heat transfer is greater because the pressure that you're putting on it. So make sure you're pressing firmly and not just like dabbing it on there, especially if that's another reason why to get a clamp is so that you can clamp it in there nice and good. Okay, I'm going to solder this up and then show you the next step. Okay, we are done with the soldering, and take a look right there. Whoa. There you go, nice solder joints. Okay, so I want to show you as we start to get to the final assembly stage. So what you should have are the potentiometers, the toggle switch. In some pedals, it won't be a toggle switch, it'll be a 9mm potentiometer like this. That will go in the same location. But you'll have a foot switch, a power jack, and audio jacks. For many of you who have the jacks included, right now you'll be actually getting 2 power jacks. And that's just because this plastic jack, I've found that some of them are lemons. And so I'm actively looking for one that's a little more reliable as far as, you know, construction. Once it's in there and that one works good, it's been fine. But I am looking for a better part. So if you know of a insulated, meaning plastic body jack like this that's a better quality, I'd love to hear it. Okay. And then, of course, you're going to need some wires. I have some pre-cut and pre-stripped ones here that I will use. Okay. All right. And then, of course, the enclosure, you're going to put it in, and then I've got some tools to tighten everything down. All right, so first we're going to start here with the toggle switch and the pots and the LED. So a couple of notes here. First of all, this is a dust cover. and it should come, if you get the pots from me, that should already be on there. You can use dust cover, you don't have to, but if you don't, then you should use electrical tape to stick to the bottom of the pot to make sure, because when you stick this on here, if there's nothing in between the pot, the metal pot and the board, you can short stuff out. So you need to either have a dust cover or some electrical tape or something that keeps it from those things from shorting out. Yeah. All right, so let's get started. So the first thing I do is I take this is my process, you don't have to do this exactly, but I take the outer two legs and I just spread them just a bit. So this one right here, to help you figure out what's what, is a dual gang pot because it has two rows. It has two pots in one. So up here it says actually, get this in the light, C100K, and on the back C10K. So this is actually a custom pot. So this, anytime this is called for in the design, I will include it because you're not going to be able to find it out there. So anyway, I spread those legs out just a touch. And then that way I can squeeze them in here and there's a little bit of pressure and it doesn't just fall out on me. So that's super helpful. I'm also removing the nut and washer as well because we're going to not need it until we stick it in the enclosure. Okay, we got that one in there. Going to do this one says B1K, and so on all of these they should be, let me get this in the video here, they should be marked, so it says B1K right there. That says D100K, C10K, C100K, so you can see that. So I'm going to put it in this one. So as I turn it over, it's on the left. Again, I spread those legs a little bit. And then D100K in there. Okay, toggle switch, again, taking off the nut and washer. Doesn't matter which way the toggle switch goes in, as long as it goes in. Okay, so there we go. And then we've got the LED. So the LED has a long leg and a short leg. You want the long leg in the right hole. On the opposite side of the circuit board, which I'll show you here, the long leg is indicated by the plus sign, the plus symbol. It's the positive. So anyway, but on this side there's no silk screen, so you're going to put it on the right side. Long leg goes to the right hole. And you stick it in there like that. And so now this is now ready to actually go in the case and start looking like a pedal. So before we can do that though, I need to prepare the case. So all I'm going to do to start is install the foot switch and the power jack. You can technically install these after you install the board, but it's just a lot easier to do so because of the room you have on this phase. Okay, so as I install the foot switch here, I want, it's designed to have when you're looking at the inside, for the foot switch to essentially point straight to the right here. I'm going to use this tool, which I got this at StuMac. It's great for these Carling switches that have the serrated nut. Okay. There you go. It's nice and solid. All right, and then the power jack. I'm going to stick that in. With this one, again, the way you install it doesn't officially matter, but to make things easier for you, I put the long leg, which is the positive one, I would put it on the left side, and you'll see that later. It helps it align with the holes on the circuit board for power. I'm going to tighten that pretty good. FYI on this power jack, do your best to really tighten it down because you don't want to lose the power jack. Okay. All right, now that's been prepared, we're not going to put in the audio jacks at this phase because then I would not be able to fit the circuit board in. So I'm going to take the circuit board leaving it face up. I'm not going to turn it over because, you know, the LED or this might fall out. I'm going to just stick it through those holes. And then put on all the washers. And I'm pressing up on the circuit board with my fingers down here to make sure that it doesn't fall out. Okay, once it's in there, I actually I tighten the toggle switch first because it's kind of the firmer part. It has less flex to it, so I want it more aligned more perfectly, if you will. And these potentiometers, because the legs have some bend and there's some wiggle room for them to go. So I tighten those second so that I get the board in there nice and clean. Again, these are details that you don't have to do exactly this way, but I've found to be super helpful. All right. Okay. So there you go. It's starting to look like a pedal. The thing I'm going to do here is this LED. If you've got the case, if you're doing this with your own case and you've drilled your own holes and all that, but if you've got the case that's pre-drilled, you'll notice that the LED, the 5mm LED, won't actually stick through that hole, and that's intentional. It's meant to go right on the underside of that. So I push it up against there, make sure it's centered on that hole, and then I flip it over, and I get ready for the soldering stage on this side to solder in those pots and switches. Now, a couple things prep notice. These dual gang pots here, you'll notice they don't have dust covers, but also because they just don't fit, but also they've got these metal tabs. And I want to make sure that those metal tabs don't short out on anything. So there's a couple things you could do. One, you could put electrical tape, but it's just as easy and actually easier, I think, to take this end of the board, and I'm just gonna see if I can show you this. I'm just gonna pull up slightly, so everything is still installed really nice and solid. It's just that this end of the board is just shifted up a little bit away from those metal tabs. And I found that that's all that you need to do. So let me get this in the picture, ready for soldering. Okay, so now what I'm going to do is I'm going to be soldering in the toggle switch and potentiometers. You'll notice that I'm doing it on this side, and I did not solder them in on the other side. And the reason for that is simply for alignment of making sure that all the pots and toggle switches, they align perfectly. They don't have undue tension on them, because if you solder them before sticking it in, you might solder them just a little bit off in terms of an angle or where the center of the, just the alignment. And if you do so, you can it might put extra tension on that part when you actually screw it into the enclosure. So that's why I do it this way. Same sort of soldering technique. I go all the way to putting the tip of the soldering iron pretty much right in that hole, so that and I put some pressure in there, put a decent amount of solder, let it flow into that hole. That's what I'm looking for that whole time. Oftentimes I will solder only one leg of the LED first, just because, just because I want to make sure it didn't get shifted off in the midst of all that stuff. And so once one is soldered in and it's all centered, I solder in the other one. Okay, let me get this a little more centered here in the video. And then I'm going to solder the dual gang ones up here. So you'll notice there's some capacitors really close to these. So make sure you're getting in there in such a way that you're not melting, that the soldering iron isn't touching any of the components. You don't want to melt those.
I should note that if a little bit of the plastic case melts, it's not a big deal. It's going to be okay. It'll work just fine. Okay. Now these are dual gangs, so they actually have 2 rows. And while this row is relatively easy to access on this side, because you got a nice gap there, the other one is a little harder to access, so I wanted to specifically mention how I get in there. This is a technique for you beginners. So I'm actually going to, so this part right here, this transistor, it can be pushed down a little bit, and it gives me a little more gap there to stick a soldering iron in. And so when I stick the soldering iron in, now I'm going through, hopefully you can see, I'm going through kind of a bigger gap. It gives me more margin for error, and that allows me to solder up that solder joint without melting anything. You can see me just rotating things around and such so that I always have the easiest access to make a good solder joint without soldering something that shouldn't be soldered, like a plastic casing on a component. Okay. Some solder joints you'll be like, wow, that one's harder than to get it to flow than others, and that's because of something called the ground pad. So the ground signal is what everything is referenced from, and because of that, we want, when you design a circuit board, you want it to essentially have a lot of metal. So it's a nice even ground plane. And so those solder joints, because there's so much more metal around them, even with all the designs, like doing a hatch design to remove the quantity of metal a little bit to make it easier to solder, and some of the other things done to make it easier to solder, there's still just at the end of the day more solder, more metal there, and so it takes more heat to heat up the joint and have the solder flow. So you'll notice that that's not unusual. Don't worry about that. You should still get a good solder flow though. All right, so all those are soldered in place, and now this thing is rigid. It's looking good. The next step is to put in all of the wires. So with these wires, if you get them from me, they're pre-cut and stripped. You'll notice that, see if I can get this up here, that one end of the stripped wire, this is longer than this end. That's intentional. The shorter end is going to go into the circuit board. So I'm going to stick it into the circuit board here, and then I'm going to fold it, and I'm going to try to get a close-up of this so you can see exactly what I'm doing here. So sticking these in. Again, your technique can be completely different. It doesn't have to be my technique. This is just what I've developed to try to not just have really good quality, but also make it efficient so that I'm not spending as much time to get good quality. And then with the foot switch, I don't usually put it in the board first. I put the I take the long end here, and I create little hooks. See if I can get this. I hook it, make little hooks there, and then I stick that in. I hook it through the foot switch lug, and then I squeeze it. Get it to stay. Hook it, squeeze it, boom. All right, let's line these back up here. Okay, now let's see if I can get you to see this. So up here is when I folded these down. Let me get something I can point with. When I folded these down here, I folded them so that there's more exposed metal, that it's not, that the this white sheathing doesn't cover the solder joint that I'm about to make, because that's where I'm going to solder. So I want to make sure that there's some of the metal kind of pulls out on the wire. Just makes it easier and cleaner to get a good solder joint without melting the white sheathing on the wire. All right, now picking that up, got it all wonky. Okay, so now I'm going to go in and I'm going to solder 8 solder joints. There we go. If you use this method, the wires might little wiggle on you, but if you can get them to steady, that's great. Okay. And then now I gotta solder in that footswitch slug. I like to, and I'll try to get this in the video with the footswitch slug, put quite a bit of solder around there. That sort of in conjunction with the sheathing protects the wires from fraying, especially if you end up having to modify or troubleshoot your build. That'll be really nice. Okay, so hopefully, I don't know if you can see in there, but that solder is not just holding it in place, it's enveloping the whole solder joint. Okay, and then now I'm going to take some pliers here, some needle nose pliers, and I'm going to route this end of the footswitch wire. There's 2 holes here in the corner. That's for the footswitch. It doesn't matter which one is which, because all it is a make and break type contact. And then I'm going to push it down to again expose that metal. So hopefully you can see that. Push that down. And then I'm also going to do with the power jack, I'm going to loop that into there. Loop and bend. All right, loop and bend. All right, now I'm going to solder those 2 things in, and then we're getting really, really, really close to having this pedal ready for testing. So let me solder in the foot switch. Get this all in the video. This solder stage is probably hardest for beginners, partly because of the weird kind of access angles, and mostly because this power jack, because it is a plastic, if you leave your soldering iron too long on the metal, it will actually melt the plastic. This is the main reason why I want to, I'm actively looking for a better part. But so when I do it, I want good flow, and then I just let it. Once it's flowed on there good, I remove the heat so that I'm not adding excess heat to. Okay. All right, there we go. All right, now I'm going to take these pliers and I'm going to pull these wires up so they're kind of sticking out like that, sticking up. Boom. And then I'm going to pull these wires down. I should note, because I didn't know this while I was doing it, the foot switch wires don't matter which way they go in. All the wires up here do matter. But if you did have the longer leg on the left side, that aligns with the positive. Longer leg is positive, and the positive here is on the left side. It's a square hole right here. And then this is the negative leg. So it goes to the shorter leg. And then that lines up nicely with the audio jacks. With these switchcraft audio jacks, the ground is the slanted, see if we can get there, the side with the slant on it, that's the ground, and this is the signal. And so I'm going to stick it so that the ground, just like with the power jack, the ground or the negative was on the right, and so I'm going to put the ground to the right on both of these. For your total beginners, ground is often what we call 0 volts. It's what we measure everything from. Think about it this way. If you were to measure how tall someone was, where do you measure from? You got to measure from the same point for everyone, or else they're not really all the same height, or you're not measuring accurately. And so that's why we use it. That's why we call it ground. It's the measuring point from everything else. So in guitar pedals like this, the negative wire is what provides the ground. It's the reference point. And so that's why sometimes you'll hear it called the negative, and sometimes you'll hear it called the ground. But that's just true in guitar pedals where the negative wire is the ground. When it comes to the audio, you have the signal swinging up and below ground, up above and down below, because it's the AC signal. And so you won't hear this called the negative wire. You'll just hear it called ground, because that's what it is, because it's flowing up above it. Whereas this, sometimes you'll hear it called negative wire or the ground. Anyway, if you install these jacks with the slanted side on the right, the wires, they just line up. So there we go. Okay, and now I'm going to solder in those wires. Again, you don't have to do it this way, but I do like to flow quite a bit of solder into these large joints. Give it a nice even coat around the hole. I just found that, especially when you have to remove them for modifying or repairing a pedal, having a nice solid bit of solder makes it less likely to get those wires to bend and fray. They're protected. All right, the last thing I got to do here is clip out the LED legs. And there we have it. This pedal is ready for testing. In case someone notices, I should point out this part is actually, this transistor is installed backwards just because I didn't have that exact one, but I had one that's pretty much the same thing except for the pinouts in reverse. So that one's in backwards. You don't do that. You put it in the right way. All right, let's get on to testing. All right, now we are on to the final testing stage and assembly stage. I'm not going to do too much testing here because each pedal is different, and you'll have to test it yourself. But I do want to note a few things. First of all, any Trimpots, these blue Trimpots that are in your pedal, the stock position is 12 o'clock, right in the middle, unless otherwise noted. And so this particular one only has a Trimpot here for the LED, and so that just adjusts the LED brightness. That's really easy to set. If it has a switch here for buffered and true bypass, the way that we set it up in the shop is for true bypass, and then allow the users to set it up for buffered. You do what you want, and you can experiment by switching them on and off to hear the difference. In many cases, the difference is negligible, if not nothing, unless you're driving a really long signal chain, and then it will make a significant difference. Or if you're driving like a fuzz pedal or something like that, then whether or not it's buffered first will make a big difference. So, all right, so that's the inside there. It's all set to go. I'm going to turn it over. One of the things that I highly recommend when you test a pedal to do first, and this is to, wow, it's just not going to cooperate with me, is it? Whatever. You can look at an angled pedal. is turn the volume down. And then turn it up just a touch, because it's fine if you turn the pedal on and it's quiet. It's terrible when you turn the pedal on and it blows your face off. So I'm going to turn that on. And then what I do is I go through each control. And so I know that this tone knob blends between these two controls, that turning it clockwise makes it blend towards a high pass filter to make a brighter tone, and then turning counterclockwise blends towards the low pass filter. So what I'll do is I'll turn it fully clockwise, and then this knob, I can really hear what it does. And this knob doesn't really do anything because it's out of the circuit at that point. And so that allows me to isolate. That's just one of the ways that I like to test, is to isolate certain sections to make sure I can really clearly hear what's going along. Now, I can't go through this pedal one by one, every single thing, because every pedal is different and the pinball is going to be set up differently. So anyway, so I do my testing procedure, and once that's all finished, I turn it off and I unplug it. Okay, and now we need to install the backplate. So that's really simple. I'm not even going to actually do it. It can go on either way. Don't worry about that. Screws are right there. They're Phillips, or you can use flathead. But the thing that I do want to actually talk about as far as for final assembly are installing the knobs. So let me put down the guitar. So if I were to just put on the knobs willy-nilly, they wouldn't, they'd stop here and maximum be over here or whatever. So what I like to do is turn them all one direction. For me, it's counterclockwise. Okay. And then your angle, if this is straight down for you, then about 30 degrees is the angle that you're going for. Also, knobs like the ones that I'm going to use here, these ones have a set screw. That's what these smooth shafts are designed for, is what's called a set screw. This one has a slotted regular head, so that's why I'm going to use this. If you've got these knobs, which I had custom made, they actually have a hex. Let's see if you can even see that. It's a hex screw, and that's really nice for production, because hex screws, you don't have to look at them. You stick them in there. Oh, there you go, and then you screw it in. But I realize that for some of you that will be a bit of a challenge, so I'm going to let you know exactly what size it is. This is the hex screw size, 5/64. All right, so there you go. Anyway, so I'm going to install the knobs really quickly on here. If you have a pre-printed graphic, if you're at the level where you're getting the graphic printed for you, you can just point these knobs that have numbers around them. You can point them to that last number, and generally speaking, that will do the trick. So I'm going to tighten them down. Now, depending on the knob, some knobs are if you push them all the way down, they get stuck, and so you got to pull them up. So we want smooth travel. We want it to start at the first number, end at the last number, be really consistent like that. So anyway, I'll show you a picture when I'm all done here, but that's it as far as final assembly, making it look good. That's the easiest part, and most of you probably didn't even need to watch the section of the video to figure that out. Thank you for watching. I will be creating some written instructions that are a lot simpler, or I shouldn't say simpler, a lot shorter, and designed more for those who have experience, to just give you kind of do this step, then this step, then this step. If you've done projects like this before and you can follow a part sheet and you know how to solder and install parts, that'll be a better way for you, because it'll just be a lot shorter. All right, thanks for watching, and thanks for supporting me on Patreon.